All right, so today we're going to kind of apply what we learned about the sum and difference angle identities in order to actually solve. Now, remember that your homework, or I'm sorry, for this week, or whenever you watch the video, I guess week one, there's no homework this week, but there is a Delta Math assignment. Please, please, please use the teacher code and log in, because even last quarter, some people did not, never actually join. So that is a problem. Okay, I'm not gonna go over the warm up like normally, but I mean I do have notes on it already posted. Okay, so we want to find the exact value of cosine alpha plus beta. I do not know what alpha and beta are, or neither do I need to know the actual value, because they give us some very valuable information here. I have sine of alpha, tangent of beta, and also what quadrant these guys are in. 0 to pi over 2. Now, I think there were some people who were confused about how to find out. Remember that um, your quadrancials, this is 0 or 2 pi up here, right? If this is 2 pi, then halfway must be pi. Half of that must be pi over 2, right? And so this must be 3 pi over 2, right? So with this, 0 to pi over 2, that must be quadrant 1. Pi over 2 to pi must be quadrant 2. Okay, so that's how I know. Okay, now with that information, um, now I like to figure out like where my triangles are and stuff, like how does it look and so on and so forth, right? So maybe I'll use this in two different colors. Actually, maybe I'll just let me erase this. Let me just use two different colors here that I think will be a little bit more helpful, right? But for whatever has to do with alpha, I'll use purple, and whatever has to do with beta, I'll use blue. Okay, but if I take a look at my sine of A here, it is quadrant 1. So this is my triangle. So it's going to come from my origin out. So that's 3 over 5. This side has to be 4. My tan here, since it's in two different quadrants, I'm just going to go ahead and draw the same triangle here, or same plane. Negative 5 over 12. Well, it's in the second quadrant. This negative, even though the way that it's written seems to be negative 5, but really the negative goes with the 12, right? Because it's negative x. And this is 13 if you use your Pythagorean theorem. Okay, so that's how I have my two triangles. And with this information, now I can kind of figure out all the sines and cosines and everything, because remember, cosine of the sum of cosine, or cosine of two angles, the sum of two angles is going to be using cosines and sines. So I want to just write that out first. Sine of beta then must be 5 over 13. Cosine beta is going to be negative 12 over 13. And this makes sense too, right? Because second quadrant, sine is positive, cosine is negative. Now, I already have sine of alpha. This is already done. So I just need cosine alpha, which is equal to 4/5. So as I'm writing this, I'm going to expand this out first. So cosine of alpha plus beta, this is equal to cosine alpha, cosine beta. The sign is not going to match, so minus sine alpha, sine of beta. Now, I'm not asking you to memorize this. You can refer to this on your packet, or you can, if you have it memorized, that's great. That would be a lot easier to work with, right? Now, all I'm going to do is I'm going to look at the values that I have, and I'm going to substitute them in, right? So cosine of alpha, 4 over 5. Cosine of beta is negative 12 over 13. Minus sine of alpha, 3/5. Sine of beta, 5/13. 5 over 13. Okay, so I have negative 48 over 65 minus 15 over 65. So if I take the difference here, I'm going to have negative 63 over 65. So I would really try and organize all my sines and cosines and stuff like that. I think that'd be a lot easier to work with. Okay, in this case, they tell me they're both in the second quadrant. So actually, I'm going to draw two triangles because otherwise it's going to be a little bit messy, right? So if they're both in the second quadrant, well, that kind of helps because I know the second quadrant is going to be here, right? I'm going to exaggerate the second quadrant, obviously, to be able to actually draw this. Now, cosecant of alpha means it's hypotenuse over opposite. All right, so 7 over 25. And again, similarly here, it says negative 3/4. But again, y has to be positive, so 3 is positive. Negative 4, and this is 5. I think this is 24. 25 squared minus 7 squared is, and then take the square, yep, 24. So this is negative 24. Whoops. And again, cosecant, it's positive, right? Because it's related to sine. It's the reciprocal of sine, so that's positive. That's fine, but it doesn't mean I can't have a negative side. Okay. So again, with sine, I will have a sine and cosine involved. So let me think. Let me write it here. Sine alpha is equal to 7 over 25. Cosine alpha is negative 24 over 25. Well, for this guy, sine of beta is 3/5. Cosine beta, negative 4/5. I like how I said I was going to use different colors, but this time I did not. Okay, so sine of alpha minus beta. Again, you do not have to memorize this. Sine alpha, cosine beta. The signs are going to match. Minus cosine alpha, sine beta. So this is really important to just expand it out first and then substitute in all your values. Sine of alpha is 7 over 25. Cosine of beta is negative 4 over 5. Cosine alpha is negative 24 over 25. Sine of beta is 3/5. So I'm going to start simplifying. This is negative 28 over 125 minus this is negative 72 over 125 minus a negative. That's going to be adding a positive, meaning that the difference here is going to be 46, 56. Bad math, bad math. 56. Okay. Or no, 44. What am I doing? Sorry. Okay. So I hope that makes sense, right? So it's really important to have known or know your previous or the previous lesson with the sum and difference of my angles. Okay, let's do a couple other ones. This is again first quadrant. So this is a little bit nicer because they're both just in the first quadrant. Nothing crazy going on here. These are my triangles. Cosine 4 over 5, 3. Tangent is 1, 6. This is going to be root 37 using Pythagorean theorem. So again, cosine alpha, I already know. That's given to me. I need to know sine of alpha, which is 3 over 5. For this guy, I have sine of alpha, sine of beta. Right, so this is alpha, this is beta. Sine of beta is 1 over root 37. Cosine of beta is 6 over root 37. So cosine of alpha minus beta, that's going to be cosine alpha, cosine beta. the signs won't match, so plus sine alpha, sine of beta. Okay, sine of alpha is, I'm sorry, cosine of alpha is 4/5. Cosine beta is 6 over root 37. Plus sine of alpha is 3/5. Sine of beta is 1 over 37. Now notice each time my denominator is always the same. So there's not crazy calculations or anything here. I got 24 plus 3 all over 5 root 37, which is 27 over 5 root 37. And no need to rationalize the denominator. We're good to go there. Okay, last but not least, another example here. We want to see what are the two different quadrants we're in. This is quadrant 1. This is quadrant 2. I'm going to draw my triangles. Quadrant 1 means my triangle is going to look like this. Alpha sine is 4/5, so 4 over 5, and this is 3. Beta triangle look like this. Tan y is going to be positive. X is negative. 13 as a hypotenuse. So I'm going to just write out I already have sine alpha, so cosine alpha is equal to 3/5. For beta, sine of beta is equal to 5/13. Cosine beta is negative 12 over 13. So when I solve, sine of alpha plus beta, that's equal to sine of alpha cosine of beta. Sine is going to match cosine of alpha, sine of beta. Okay, so sine of alpha is 4/5. Cosine beta is negative 12 over 13. Plus cosine of alpha is 3/5. Sine of beta is 5 over 13. I'm going to multiply, simplify, negative 48 over, this is 65 once again, plus 15 over 65. So in this case, I get negative 33 over 65. All right. So I hope this helps. Again, it's really just important, I think, to figure out what quadrant you're in because that is going to affect your positive, negative x or y values. Not only so, you want to write out all your sines, sine of and cosines of each angle of your alpha and beta. Okay? I hope this video was helpful. If you have any questions, please feel free to ask. Thank you.